All right, section 4.1, we started last time. We got almost done with it, but just let me remind you kind of where we were. We had talked about derivative rules so that we could develop the antiderivative rules. And these were the first half, basically, of the antiderivative rules. When you have a 0, you get a constant, capital Y. We use capitals for the antiderivatives. When you have a constant, it has an x attached to it. It becomes a linear function. So kx is what we had here. When you have a constant multiplier, that is, you have a number times a function. That number just stays a part of the function, and then we take the antiderivative of the function itself. With sums and differences, we treat them just like what we did with the derivatives. We take them individually. And then the power rule, we increase the power by 1 and we divide by the new power. And of course, on all of these, we have a plus c, plus a constant. We talked about that being that shift, vertical shift up and down from where the function could have lied with the c equal to 0. And then we had these trig rules. All of these we recognized as being without potentially the negatives. The list of derivatives of the trig rules that we originally had. So if we started, for instance, at the antiderivative on the right-hand side of this, the one that's actually written out, and we took the derivative, we'd get back to the left-hand side. So that's how we created this list. And we had gone through 6 examples, and we had 1 example left. Oops, this one right here. All right, so if you take a look, I'll just flip one screen back. There's a couple of things that are different looking about this. On these particular problems, you have that script s with the dx at the end. That notation just means find the antiderivative. And actually, I think it was Grace and I that were discussing at the very end of class last time about integral. Was that it? You'll hear me sometimes use the word integral interchangeably with antiderivative. They mean the same thing. Specifically, right now we're talking about indefinite integrals. That was one of our definitions. In fact, it was the only definition in this section. And so for short, I would say an integral. So if I say integral or I say antiderivative, that means the same thing, okay? And we'll talk more about the other kind of integral later, which is a definite integral. Anyway, so you'll see the notational difference between this slide and this slide. You'll also see that there's this sort of information given at the end here that's different. They actually tell you f of 1 equals to 2. That's something that's different. We weren't given that extra sort of statement on any of the rest of them. Now, aside from the part that's underlined in red, the question's actually the same question. It's just phrased differently. They ask you to find the function f of x, and they give you the function f prime. Okay? So what we were working on in the previous slides is we were given a function, and we were asked to find its antiderivative. That's the same statement. It just didn't have the f prime and the f listed anywhere. It had that integral notation instead, that script s at the beginning and the dx at the end. So we're going to take this function right here, which is a derivative function, and we're going to find its antiderivative. All right, so I know it's been 2 days since we've done any of these. But the 12 at the beginning is a constant, so it stays put. X squared is a power rule. So what do we do for x squared to do its antiderivative? X cubed, and then over 3. Right? We add 1 to the exponent and divide by the new power. Then I have a plus sign. That's that sum difference part. And I've got the derivative being 2. That would become 2x. And then I need to do one more thing, plus c. There's one step to simplify on this. What can I simplify? The 12 and the 3. These two reduce to become the number. Don't everybody say it at once. All right, 4, thank you, yes. 4x cubed plus my 2x plus my c. So what you'll see that we've done is nothing different on this problem yet. But the last step on this problem, and this is the information they give us right here at the end, allows me to actually figure out what c is. So sometimes you'll hear it referred to as an initial condition. It actually gives you some kind of information about the function f of x. In particular, on this one, it tells you that when x is equal to 1, and we can fill in the 1 for all the x's, then the whole function value is going to equal to 2. So the only thing that we don't know in this particular expression now, or this equation, is the value c, and we can find it. So this is 4 plus 2 plus c equals to 2. 6 plus c equals to 2. So what is c? -4, yeah. Now you want to be careful that you don't just stop there because you didn't actually answer the question yet. You've got all the pieces to the question answer, but you have to put it all together. It actually wants you to find the function f of x. So f of x equals the 4x cubed plus 2x. And then we want to insert what c is, which is minus 4, into the problem. Okay, so it's just a real simple little algebra step on the end. That's all it is. I mean, pre-algebra almost. Okay? Any questions on that process? All right.